All right, we are recording.
Great work. Okay, so as I mentioned, I'm going to be talking to you today about AWS logging, and specifically at scale and in the most resilient way possible that I'm aware of. This presentation was delivered at our user group by myself and my colleague and one of my engineers, Tomasz. This came from a customer requirement to essentially build out a validated architecture for one of our customers who wanted to do this, but as you will probably know if you've tried it, there is a lot of different options, both on the AWS side and on the Splunk side, for ingesting these kind of logs. And although my kind of day job is very focused on security, this is very much more generic. This isn't going to focus on a particular log source, but try to give an overview of the two primary ways that you should do it, and then the 1/3 way which you have to for a couple of different log sources. It's quite dense in the sense that you can go really deep with this topic, and AWS, Amazon Web Services, is an incredibly broad platform. I think it's got 74 odd different services and verticals that it works in, and we're going to obviously be touching upon them, some of the most common blog generating services as part of it. Just to give you an idea, when we talk to our engineers about this, it's a 3.5-hour workshop. So yeah, this is condensed, but hopefully still be interesting to the majority, if not all. And these slides are already shared online and can be obviously shared at will as well. So first of all, and this isn't because I expect everyone to get this image straight away, but this is what we're going to be talking through. So the primary weight here, so everything in the center and on the left-hand side, discusses the three primary ways to bring stuff into AWS. And what I'm now going to do is break each one down and talk you through it. So first and foremost, we have SQS-based S3 inputs. So SQS is essentially a message bus and enables you to put messages in it to be consumed and pulled down. S3, an object store, is a place that you can write logs to then be consumed by, again, a pull. So that enables a heavy forwarder or indexer to have the AWS TA installed, the inputs configured, and for it to pull it down. Now, the importance of it being SQS-based is that maintains an understanding of state. So what has been pulled down and what hasn't. You can do normal S3-based inputs, but what will happen if you spin up multiple heavy forwarders is you'll get a ton of duplication in your logs. So what you actually need is something that maintains state on the AWS side, knows what has already been consumed by Splunk and what hasn't. So that therefore means that you can set up quite a highly available and distributed infrastructure, because you can at will spin up as many heavy forwarders as required for log volumes and performance requirements you have. It's very versatile, obviously. So S3 itself on the Splunk side, its object store, is highly durable and resilient. SQS also is maintained at a similar level of availability, and you could set automatic scripts and so on your heavy forwarders that said, well, if your heavy forwarder goes down for any reason, just to spin up a new one, or indeed auto scale them out. Because the state is maintained on Amazon's side, it means that it doesn't really matter the state of the heavy forwarder. You can only really miss a couple of megabytes here or there of data, and that's only in certain conditions. But generally speaking, it means that you're going to get your data and it's going to come through at scale, because the object store scales out almost indefinitely as far as file size and amount of access and so on. Some of the drawbacks is it's not exactly real time in the sense that it is going to be a pull. There is going to be a Python script on the heavy forwarder that's going to be scheduled, it's going to run, it's going to pull down. And obviously this requires the logs to have already be written to S3, which happens in various timeframes depending on the service that's writing to it. From an architectural perspective, it does appear quite complex. Once you've got it set up, it's relatively straightforward, but conceptually speaking, having a message bus maintaining state on AWS can come across as quite complicated, but it does work and it does scale really well. Some of the kind of out-of-the-box data sources that it works really well with, things like your access logs, your ELB, CloudFront, S3 access logs, AWS config, and AWS CloudTrail. But as a custom data source that you can essentially pull in anything that can log to S3. Secondly, and my personal favorite is Kinesis Data Firehose. So rather than this being a pull input that Splunk runs a script and pulls down, this is a push input. So this is AWS spraying data, so to speak, at a heavy forwarder or indexer that's running the HTTP event collector. For those of you that don't know, the HTTP event collector is essentially part of the Splunk Enterprise stack that enables it to receive logs in the HTTP format and consume them in a secure way. So it's tokenized via TLS and enables you to, therefore have an exposed online endpoint, and anything that sends it to a specific port with a specific token will then be written to disk as you'd expect. The benefits here is, again, you can scale out your HEC collectors, your HTTP event collectors, almost indefinitely. So you can just put them behind a load balancer and then it will spread the load. So again, you can set up auto-scaling groups if you wanted to that would look for things like network throughput, CPU utilization, memory utilization, and then scale those out as required. Because it's HTTPS, you also have a form of message integrity, so you're very unlikely to lose data. And even better, Kinesis Data Firehose actually has a custom built Splunk component which enables you to do indexer acknowledgement. So straight from the AWS side, it's going to be sending events in a way where it's checking for state and checking that Splunk's telling it that it's been written to disk. So for your, for data that you absolutely cannot afford to have any form of drop, this is the best possible option. And there's a number of cool things you can do with it. So obviously with these features, it makes it both highly available and distributed. It's real-time-ish in the sense that nothing is 100% real-time, really, but it's probably the closest you're going to get, because as soon as the Kinesis Data Firehose receives a piece of data via what's called a shard, which I'll not go into, but that's the compute inside it that takes data and moves it through, it's going to then send it as an HTTP message straight to your HEC collector. For now, there are only a couple of sources that are supported out of the box, so VPC flow logs and guard duty events being two of the largest. You will need a separate Firehose configuration per source type. And right now, there is a limitation within the AWS web console that you will actually need to use the AWS API via its command line tools to actually set this up properly. It's a bit frustrating, but I'm sure Amazon and in partnership with Splunk will be trying to improve that integration. It's also important to note that Splunk, outside of AWS's own data analytics stack, is currently the only out-of-the-box supported big data provider for this, just as a testament to their partnership, and therefore made it really quite straightforward to set up. I think they're the main things. So you can obviously push your custom data sources this way as well. You just have to bear in mind that, out of the box, it's going to require some configuration. So, and finally, I guess the most standard way and the way that most people start with AWS inputs is the normal API-based pull. So this is a heavy forwarder, an indexer, or a search head that's been set up with the AWS TA, and the inputs are being configured through the web UI. So this is adding in your account username, your key, and then you're just going, right, I would like some S3, please, and it will pull it down. Or I would like, my CloudWatch config events, please. Okay, and it will just pull them down. Now, the problem with this is that it's not highly available. It's very, well, it's not very difficult. I'd say it's moderately difficult to make this resilient to failure. There's, to my knowledge, no way to distribute it in the sense of, you can't have two heavy forwarders configured to be doing this in an active-active type configuration, which means while you might be able to have an active-passive configuration, i.e. a heavy forwarder that's actively pulling down data, and if it fails, it fails over to a secondary, there's no way to really scale it. Now, that being said, there are a number of inputs that are currently only supported via this method. Inspector, config rules, CloudWatch logs, description, and billing. These are currently only supported via this method because AWS essentially doesn't make an easy way of getting this data out in any other way. If you can write them to S3, you can obviously pull it in through through the SQS-enabled S3 input. But it is very simple. So from a dev perspective, or if you're wanting to get up and running quite quickly to demonstrate the value or to test a data source, it can be really useful just to configure and see what's coming in. It's virtually available for almost any data source within AWS, because AWS is open API, makes it very easy to pull down data. And all you have to provide it with is obviously your user credentials and key. So I recognize that I've just dumped an absolute ton of acronyms, architecture, and AWS specific bits and pieces. But that hopefully gives you an idea of the three major ways to pull in data. It's not exhaustive, that's not every single possible way. And I'm going to talk now about a few other things to watch out for. So first and foremost, so permissions are obviously an important component of any control system, ensuring that only the right people, services, and systems have access to the right things. Now, Splunk is no different in that when it's doing the things that I've described, it needs the permissions to do so. Not only does Splunk, but within your AWS account, all the various services and components each need specific permissions to be able to move logs and data throughout the AWS environment. Now, very permissive permissions, i.e. open to most do things, will involve things like stars. Stars are very dangerous, generally speaking. You'll know this from searching index star, and as well as in your permission set, you also don't want to have resource star, because that means that you've told whatever that policy is attached to that it can access any resource within that account, within that service. So it's much better to be very, very prescriptive in what you're allowing it to do, both as far as the action, i.e. the action that it's going to do to the record, to the piece of data, but also to the resources you're giving it action to. The problem, of course, with this is it gets complicated, especially with large accounts. Now, Splunk's kind of out-the-box listing of permissions are quite permissive. They do allow you to do quite a lot of things, but they at least do get you going. So I would recommend that, again, when you're playing with it in a dev environment, start with Splunk's stack, and then go down further. If you do work in an AWS environment, hopefully you already have AWS engineers and experts that can advise the right type of permission set for the thing you're trying to do. One of the things that is, from my perspective, and something we've played around with recently, is linking relatively arbitrary data. So this is kind of pre-trained, non-pre-source type data, putting it into S3 and then pulling it in the way I mentioned earlier. So the SQS-based S3. So this essentially says that whenever you've got events that are put into a bucket, you're going to tell it to put it on that message bus ready for Splunk to consume. This means that if you're writing anything to, say, CloudTrail logs or into a bucket, you can actually set Splunk to consume them in that same highly resilient and distributed way, but without the need of developing anything custom or using Lambda within AWS or something similar. So I think that's really useful, and we've been using this for a number of custom data sources where the customer wanted them to be highly resilient and scalable. A few things. When it comes to setting this up. So you will almost always run into problem number one straight away, and that is a permissions problem. Like a lot of things when it comes to accessing data, and that can be whether it's obviously on your local host, a remote server, or an entire public cloud, you're always going to need permissions to do the thing to the thing. This is mentioned twice in this slide because it's actually something that will catch you out time and time again. If you have a problem, it is likely to be something to do with permissions. Within the AWS config itself, there are a number of things that it will collect metrics for, and therefore it will tell you if things are managing to actually push through the system or not. This includes S3, Kinesis data Firehose, and so on. And then obviously on the Splunk side, Splunk is incredibly voluminous in its internal logs, and it will give you the chance to actually look for any issues and errors within it. The AWS add-on also contains a health check dashboard, which will try to help you troubleshoot some of the common issues. So I think we're close to the end. So this is the same slide that I put up right at the beginning. So this is all three of those components in. At the top, we have data flowing from the left to the right, going into an S3 bucket, the message bus being updated. Splunk checks with SQS at the top and says, is there any data for me stored in S3? And if there is, it will pull it down. In the middle, we have Kinesis data Firehose, where again, logs being generated on the left move through the system. They go through Kinesis data Firehose, and then they get pushed via a load balancer to the HTTP event collector. And then finally, we have the relatively, let's call them dumb, API-based inputs, of which you can only pull down and therefore are very difficult to scale and also is not highly resilient. So again, I recognize there's a lot of information that's been dumped, and if you're not native to AWS, some of this might have seemed quite confusing. So I've made sure to leave quite a bit of time for questions. That is the presentation, so please do ask it away.
So Harry, I have one question. Since we deal with healthcare data, I can't use Firehose because it goes out past my VPC to the internet to come back in. Have you found a better way to do that? Not in the ones I've used it for. So because we've been going with, yeah, you can't use a VPC peering with it, can you? No.
For now. No. So that's the only way I've used it, to be honest. It's a TLS encrypted tunnel, so there's an element of data security, but obviously if it violates your security architecture, then you're going to have a problem.
Yeah. Okay. What other questions?
I suspect it might be a feature request, because it would be the kind of thing that should support, a rooted approach where you can either put it into the public web or via a VPC peering type setup.
Yeah, I have the feature request in, and I actually talked to the AWS engineers at Conf, and they said soon, but soon isn't. Their soon and my soon don't look to be aligning.
Yeah, it's a shame. It's those kind of things that make a great feature stumble a little. Yeah.
Questions?
We don't use AWS company in our future, but is Kinesis Firehose anything like the PCF Firehose? I'm not familiar with.
I don't know that Firehose that you're talking about.
Cloud Foundry.
Oh. Do you know you want to speak loud because the mic's way up
Are you
here.
familiar with Public Cloud Foundry Firehose? Is that the same or similar to Kinesis?
So I'm not familiar with that either, unfortunately. My experience so far from a Firehose perspective has only been with Kinesis data Firehose. I don't know whether it's just a synonymous name or whether it means there's a comparable feature set.
From what you described, it's very similar. We use
Okay.
internal cloud.
Yeah. So other than the indexer acknowledgement component, which is to my knowledge the only kind of Splunk specific part, there's no reason why the HTTP event collector couldn't, if it can send out its data in an HTTP form, and and using certificates encrypt the data and embed the token that Hex waiting for, then there's no reason why it shouldn't work. So that would be again I don't know how that Firehose scales, but that should be a very scalable way of sending data into Splunk, because generally speaking, pull is very hard to scale because you have to maintain state at source.
So actually how I'm doing it right now, I'm taking the CloudWatch logs into the Lambda function, and a blueprint, which is directly sending it through the load balancer to my HEC. So the Lambda function, we just say if it watch these CloudWatch log sources, into that source off push. I'd love to though take the Lambda out and use the Kinesis Firehose directly until we can get the secured method internal only. I can't do that.
So explain the security issue there, because that'd be something we.
So because it's HIPAA data,
Right.
I can't send it across unencrypted public networks. It goes out in Firehose to whatever my instance we have to divert the public internet.
And you can't send that
The complexity then goes up, and if we were just able to say internal only traffic, then I wouldn't have to worry so much.
Yeah. And from a regulatory perspective, although the actual transmission stream is encrypted via TLS, when you use Kinesis Data Firehose, the problem is it's transversing a zone that is outside of your scope of control. And therefore, although you can say, but we use, public perfect for secrecy and we're using an encrypted tunnel, yes, but it's going into a network that you don't control. And that is, to a point, a legacy perspective, in the sense that, well, if you're using up-to-date ciphers and so on, that it should, in theory, still be as protected. But of course, often these regulations are, from my perspective, in things like PCI DSS and so on, they're often, in a place that was built for on-prem data centers, where if you were sending data external to your data center, that was an incredibly dangerous thing to do. Public cloud, obviously, is more of a hybrid model where you have, yes, your zones of control, like your VPCs, but you also, a lot of things are accessed via the public internet.
There it is, brother. Why are we going so slow?
Yeah. Any other questions?
Hello. Hi, Harry.
Hello.
I've been bothering you on Slack over the months here. I really like this diagram. I'm just curious if you know, or if anybody knows of kind of any thinking Splunk has on the add-on and all these modular scripted inputs stuff, like that doesn't seem like that can be the thing to hope and cherish going forward. Like you mentioned, the whole just sort of having an account emit all this stuff as part of its otherwise like baseline configuration and just push everything out the heck. Like that is ideal. And the fact that it doesn't seem possible basically to avoid these modular inputs. I guess I'm just looking for if anybody has any comments on when we can do away with this add-on thing.
Sure. So I think it's part of it depends on AWS. So to my knowledge, I don't think there's actually a way to consume inspector, config rules, CloudWatch, description, or billing except over a pull API request.
Right.
So the way around that is you could configure a Lambda function, which is a small piece of compute that you have a script running in that could pull those in and store them into S3, for example, or push them to Kinesis Data Firehose. It's not something, it's on our backlog to look at, but you could kind of take the modular input out of Splunk and essentially embed it within AWS itself, which is typically going to be more highly resilient to failure than your bog standard homegrown configuration within Splunk. And then that way would give you, only two methods of ingestion, one still being pull, but maintaining state within the cloud via SQS, and then the other being push.
And that's certainly something, we've been considering, but that's all, that's developing, like the Lambda functions for, like, it seems each case, and I guess that no one's really tackled that, or like it's not been readily community sort of level available or whatever, these functions.
Yeah. I think so. The good thing is with the inputs at the bottom of the screen, they are usually all quite low volume.
Right.
I think description gets updated, I think it's every 4 hours, and that's on the AWS side. Billing is, I think, maybe 8 or daily. CloudWatch is faster, but I think there's a delay of up to half an hour. So when it comes to the requirement of that near to real time monitoring, those inputs probably aren't for you anyway. Whereas things like your VPC flow logs, guard duty, ELB access logs, etc., typically speaking, and at least in my experience, you're going to be more interested in those from a security operations, IT operations perspective. Especially things like CloudTrail, where where you've got configuration changes in your cloud, which could be an S3 bucket with all your key data being leaked and so on. The only thing that I would like to see in there more, I think, would be CloudWatch. It would be great to see CloudWatch which is going to contain all your performance data, being a bit more scalable would be my primary.
Yeah, so that was one thing I was wondering about it concerning the diagram. What's the distinction there between CloudWatch, Azure? I think you got where I'm going with that.
Yeah, so there's CloudWatch and CloudWatch Log. So CloudWatch itself is AWS's monitoring function that looks for a number of key metrics. Think of it as the thing that monitors your VMs and a number of other things. So
Right.
it's going to take things like your compute level, so your CPU volume, your memory, your storage, your network. CloudWatch Logs is almost like a sub-feature of CloudWatch that enables you to store other logs from other services within it. So
Gotcha.
it's almost like a dumb S3 bucket underneath CloudWatch.
Okay.
But it turns out they can be consumed differently, which is a bit odd, and I'm not entirely sure why. But that's just the options that are there.
Great. Yeah. I really appreciate on this. This is because it's just such a huge lots of moving pieces. And
yes, and there's different advice even from Splunk, because there are multiple ways to do it. And one of the things that obviously as an architect I come back to customers with is, well, what are your requirements? But unfortunately, most of my customers anyway, they're not necessarily on the most mature journey with public cloud and with things like this. And I'm not an AWS expert at all. I've never done it in earnest as an engineer specifically in AWS, but I've needed to kind of learn the basics here to advise my customers, say, well, look, after about 8 hours working from home on a giant whiteboard, taking all the best practices I could find, and then asking one of my engineers to kindly write the config for me alongside, and then testing every single one out and going, right, this currently works. But both Splunk and AWS have their own roadmap, so who knows what the future is going to be like. But at least for now, this works and is as scalable as possible. But if anyone does discover more information or has a better way of doing it, please do reach out either on Slack or give me a tweet, because I'd love to keep updating it to make sure that it's still the best advice possible.
Certainly. Thank you, sir.
No problem.
All right. Thanks, Harry.
No problem, guys. Enjoy the rest of your day, and I'll see you all soon, hopefully. See you at Conf.